Hello there, welcome to this lesson. We'll be looking at curve sketching today based on question 7 of our question paper, and we will also be looking at how to manipulate a given equation. Right, so let us take a look at the question. Here it is. Great stuff. I believe that you have your notepad with you or pen and paper so that you can work along with me as we interact with this question. So 7a, we are asked to draw these two graphs, okay? And in so doing, we need to indicate these three important characteristics about them: asymptotes, intercepts, as well as points of intersection, if there are any. Okay, what type of functions are these? These are exponential functions. Good. So the first thing that we need to talk about is this: asymptotes. What type of asymptote exists in an exponential function? It's a horizontal asymptote. Good. Now, what in the equation will give us an idea? What is the constant there? It's 0. What is the constant there? It's 0. So the equation of our horizontal asymptote is y equal to 0. Where do we find, for every point, the corresponding y coordinate will be 0? We find this to happen on the x-axis. Okay, so basically the horizontal asymptote is already indicated. We don't have to do it or indicate it with our pen or pencil or colors. We can just leave it at that. Okay, the next thing is intercepts. Okay, x and y intercepts, or sometimes it is just y intercepts, as you will see in this case. So how do we get the y-intercept? We'll know that our x must be 0. So here, we're just going to let our x equal to 0. And this will be 3 to the power 0 plus 1. What does that give us? 3. And then this side, we have g of 0. It's raised, or it's 3 raised to the power of 2 times 0, giving you 3 to the power 0, and that is 1. Okay. So we are ready to indicate our points on the Cartesian plane, and we know that this is the y-intercept of f, and the y-intercept of g will be at 1 right here. Okay, so those are the points neatly indicated. What type of functions will they be in terms of progression or the behavior? They will be increasing functions because the base here is 3 and also the coefficient of the power is positive 1. So we expect to see an increasing function. Okay, so therefore it will have no what? X-intercepts, because already the boundary here is the x-axis as the horizontal asymptote. Good, so we are done with this guy. What we need now is the point of intersection. So how do we get the point of intersection? This is a common point of f and g. So what can we do about this? We know that at the point of intersection, f of x will be equal to g of x, meaning that the x coordinates will be the same as well as the y coordinates will be the same. It's a common point. So we substitute our expressions. Okay, equal bases implies equal exponents in this type of equations, right? So we equate the exponents. X plus 1 must be equal to 2x, all right? So therefore, what do we know? X must be equal to 1. So it means when x is equal to 1, there is some point of intersection where at some y value that we need to find. We can use f and find f of 1, which is equal to 3 to the power 1 plus 1, which is 9. So when x is equal to 1, right here at 9, the point of intersection will be there. Okay, you can convince yourself that even if you use g, Okay, you put 1 here, you will see that you have 3 to the power of 2, which is also giving you 9. Okay, are we ready to sketch? Yes. Okay, now we know that the graphs approaches the asymptote, but they don't touch the asymptote. Is a boundary, so goes through this point. And what is that? That is our graph f. Okay, graph of g is the graph of g. Will also go through asymptote. Okay, and this is g. Good, makes sense. Good. Okay, so we are. Okay. So this is the type of solution that was expected for question 7a for 6 marks. Easy peasy, and definitely you can get it. All right. So what do we see? The graph of g compared to the graph of f will be steeper. Okay. So that is the trend that we see here, that after the point of intersection, you'll see that g is actually above f. Okay. So that is an important observation that we make there, because then the follow-up question can be find values of x where g of x, for example, is greater than f of x. All right, so obviously a point of intersection will be a reference point in that case. Great, so this takes care of question 7a. Let us move on to question 7b, the next one. Have a look. Okay, great stuff. So in this question, we're asked to rewrite this equation here in terms of x. Okay, so x must be equal to some expression. And how do we manipulate this? We need to obviously be aware of exponential laws when we're given powers, and perhaps use logs somewhere down the line. Okay, so let us see. This one is going to be left as it is, and we can just break down this guy on the right hand side into 3 to the power of x times 3. Okay, and we need to group these two powers. How? By division both sides. Okay, by that power, and you will notice that this power is never equal to 0, so definitely we can divide by this 3 to the power of x, and cancellation will happen, and we'll have a to the power 2x over 3 to the power x equal to 3. Okay, how do we isolate the x here? It's an exponent, so we need to bring it out like this: a to the power 2 over 3 all raised to the power of x. Again, applying exponential laws, is equal to 3. Okay, so if you were to write x equal to some expression, what will it be? Notice that x comes down here. Okay, it was an exponent, so the base was this entire fraction, so it will maintain its purpose as a base even in the log expression. So we have log base of what? A squared over 3, okay, of our output there, which is 3. Okay, so this was the expectation for question 7b. You can also put brackets there to ensure that it's neat and tidy. Okay, if you wanted to continue from here and apply your log laws for division, you can go ahead and do that, but it is sufficient to leave it here to still get full marks. All right, so this takes care of question 7. We are now heading off to question 8. Right, so see you in the next video. Thank you for tuning in. Sharp, sharp.